Hello students, I am your science teacher Mrs. DEEPTI TAMHANKAR from Adarsh Education Society. Last video we saw force part 1. Now today we will see force part 2, continuation of the same lesson. Student, we saw in previous video about what is force and there are different types of forces. Now we will see inertia. It is the related term with the force. Inertia is the tendency of an object to remain in its existing state. There are different types of inertias. Inertia of the state of rest. An object in the state of rest cannot change its state of rest due to its inherent property. This property is called the inertia of the state of rest. Then inertia of motion. The inherent property of an object due to which its state of motion cannot change is called its inertia of motion. And directional inertia, the inherent property of an object due to which the object cannot change the direction of its motion is called directional inertia. So what you have understood from this term inertia? Inertia is basically the state of that object. If the object is stationary, it will remain stationary, or if it is moving, it will be in moving condition. Unless and until the force is applied to an object, there is not going to change in its inertia. Student, you have one activity in your textbook. Take a postcard and keep it on a glass. Keep a 5 rupee coin on it. Now skillfully push the card. The coin will straight away fall in the glass. After doing this experiment, you will realize that after giving a push, that is giving a force to the card, the coin, because of gravitational force, the coin is falling down into the glass. So here it shows again about the inertia, that unless the force is applied, the coin is not going to fall into the glass. After applying force, the coin falls into the glass. Understood? Student, again another example of inertia. This is Newton's first law of motion, inertia, what we saw in previous slide. Again, an object will not change its motion unless acted on by an unbalanced force. If it is at rest, it will stay at rest. If it is in motion, it will remain at the same velocity, that is same speed. Objects with a greater mass have more inertia. It will take more force to change their motion. These are the three basic laws of motion which were invented by Sir Isaac Newton. The first law of motion, that is also called as inertia. An object will not change its motion unless acted upon by external force. Second law of motion, the greater the mass of an object, greater will be force required to change its motion. And third law, to every action there is an equal and opposite reaction. These are the basic law of motion which Sir Isaac Newton have invented. Student, up till now we saw what is force, different types of forces, inertia, Newton's 3 law of motion. Now we will see unit of force. Force is a measurable quantity, so it can be measured. It can be measured by using spring balance. Sir Isaac Newton have studied in motion and force, so his name is used as a unit. Newton is unit for measuring the force. Another unit to measure the force is called gravitational unit, that is kilogram weight. 1 kg weight is the force with which an object of mass 1 kg is pulled towards the earth. So 1 kg weight is equal to 9.8 Newton. Of force. A force cannot be seen. A force can be judged only by the effects it can produce in various objects around us. A force can produce the following effects. It can make stationary object move. It can change the speed of a moving car. It can slow down or completely stop a moving object. It can change the direction of a moving object. When a player is in the game of football, kicks the ball to his friend, he changes the direction of the moving football by applying force through his kick. It can change the shape of an object. While making chapati, we can change the shape of dough by applying force with our hands. A force can change the size of a rubber band. The length of the rubber band increases when it is stretched. So these are the effect of force. Pressure. To understand pressure, take a book and place it on your palm. We feel a downward force on our palm, which is exerted by a book. The force spread over entire palm. Now try to place the book only on your pointer finger. We feel a force again, but it presses harder because this time the force is acting on our finger, which is a smaller area as compared to our palm. Thus, we observe that pressure is interrelated to force, and pressure is a force acting on a unit area. So, what do you understand? What is pressure? Pressure is a force which is acting on a unit area. Students, pressure depends on two factors. Magnitude of force applied. More the force applied, more is the pressure. And second is surface area. Pressure is depend on the surface area. Greater the surface area, less will be the pressure. Less the surface area, greater will be the pressure. You can see the above given picture in the slide, and you can understood high pressure, lesser area, more area, low pressure. So the unit for measuring force is Newton, that is N, and area is measured in square meters, that is meter square. So the unit of pressure is Newton upon meter square. The SI unit for measuring pressure is Pascal, PA, and it is expressed in Newton upon meter square. It is named before Blaise Pascal, a French mathematician and physicist. Pressure on solid. This example which you can see, it is the best example of pressure in solid. As you can see, first picture there is no book kept. In second picture, books are kept evenly. So there is no pressure exerted. But in the third picture, books are kept on top of it. And because of that, the surface area is decreases, the pressure is increases, as we saw earlier. So pressure on solid, air pressure is exerted on all the object in air. When weight is kept on the solid object, pressure is exerted on it. This pressure depends on the value of the weight and the contact area between the two. Pressure in liquids. Liquids have weight and they exert pressure on the walls of the container. Pressure exerted by the liquid at the bottom of the container depends on the height of the column. Pressure exerted by a liquid increases with the depth. The pressure in a liquid at a given depth is independent of direction. At a given depth, a liquid will exert the same amount of pressure in all directions. This can be verified by placing a pressure gauge, a device used to measure the pressure, at a certain depth in the water and rotating it in different directions. A manometer is a simple pressure gauge, a device used to measure the pressure. Pressure in gas or gas pressure. Air is a mixture of all gases, you all know that. All the gases are made up of tiny particles called molecules, which moved around quickly in all directions. The fast moving gas molecules collide with one another and with the walls of the container in which they are kept. When the fast moving gas molecules collides with the wall of the container, they exert a force on the walls of the container. This force produces gas pressure. Understood? Means if a balloon is inflated by feeling air by mouth, it inflates on all sides. And if a pin hole is created in the balloon, air leaks out and the balloon does not inflate fully. It is realized that like a liquid, gas also exerts pressure on the wall of the container in which it is enclosed. All gases and liquids have a common name, fluid. Fluid in a container exert pressure from within on the walls and the bottom of the container. A fluid enclosed in a container exerts its pressure equally in all directions at a point within the fluid. We learnt about inertia, pressure in solid, liquid and gas. Now next concept, that is atmospheric pressure, buoyant force, Archimedes principle, we will see in the next video. Thank you.